Hello students, today we are covering 7.1, the second half, and this is on multiplying and dividing rational expressions. Please put your name and the date. Alright, by the end of this section, you will be able to multiply, let me zoom in, rational expressions, and you will be able to divide rational expressions. And then you'll also be able to multiply and divide rational functions. The step 1 for multiplying rational expressions is to factor each numerator and denominator completely. And that's why in our last class we were simplifying by factoring, because that makes your multiplication a little bit easier. So we want to do this completely. Then you're going to multiply the numerators and denominators, and you will simplify by dividing out common factors. So let's look at example A, and then we'll work on example B in our groups. Noticing that in example B, there is something that may need to be changed into its opposite after you do difference of squares. All right, let's look at A. We're going to factor. You could factor 9x squared into 3 times 3 times x, but that's a lot of writing, and I think that you're advanced enough to know that we'll just end up canceling out anyways. So we have in the denominator factors of 30 that add up to 11. It's 6 and 5. So we have x plus 6 and x plus 5. Then in the numerator of the other factor that we're multiplying, we have x squared minus 36. You should be recognizing that that's a difference of squares. So we have x minus 6 and x plus 6. Then in the denominator we have 3x squared, and in the numerator here we have 9x squared. I'm actually going to go a little bit out of order. I'm not going to multiply these yet because I know that this x squared and this x squared cancel, and then the 9 and the 3 cross cancel, and the 9 becomes a 3 because 9 divided by 3 is 3. So this all cancels, making our job a little bit easier. And then we can also cancel this x plus 6. So what we're left with is 3 parentheses x minus 6 and x plus 5. And we'll leave it like that. That is as far as it can simplify, and that's what we get when we multiply it out. Now we're going to look at dividing rational expressions, and just remember that P, Q, Q, R, and S in this example cannot be 0, because then we would end up dividing by a 0. So these cannot be 0, and the reason why is because we're going to multiply by the reciprocal. So to divide rational expressions, multiply the first fraction by the reciprocal of the second. And when I've taught this before, when we multiply the reciprocal, I say keep, change, flip. So the first expression, rational expression, you're going to keep it the same. You're going to change it to multiply, and then you're going to flip it to the reciprocal. Okay? So because you're advanced, I went ahead and gave you this sum of cubes, even though I probably won't test you on it. So in the margin, I want you to write sum of cubes. This is another special type of factoring, because if you have a cubed plus b cubed, it factors to become a plus b and a squared minus ab plus b squared. Let's start with factoring p cubed plus q cubed. So that's going to follow that same pattern, p plus q, p squared minus pq plus q squared. And then in the denominator of that, we have a 2 that can factor out so that we have p squared plus pq plus q squared. And then we're going to, instead of dividing here, this is where I'm going to change it. So instead of dividing, I'm going to change this to multiply. And I'm going to flip this to the reciprocal, okay? So in the numerator, we have 6, and in the denominator, p squared minus q squared is a difference of squares. So we have p plus q and p minus, not 6, q, right? And so that's now in the denominator instead of the numerator. So we can cancel a p plus q and a p plus q. We can also simplify the 2 and the 6 to just become 3. And I believe now we can multiply, and I don't think that we can simplify that further. But if I'm wrong, let me know, and we can go further with this. For C and D, we're still dividing, and what we can do here is multiply by the reciprocal. So let's put that in our Cornell notes. Multiply by the reciprocal. Or sometimes I say keep, change, flip. So we're going to keep the first part the same. So the numerator is going to be the same. We're going to keep it 6x squared, which I think I have room on the side. 6x squared minus 7x plus 2 over 4x minus 8. Now instead of this fraction bar that we have, I'm going to change it to multiplication, and I'm going to flip what's in the denominator. So on the numerator, we will now have x squared minus 5x plus 6, and in the denominator, we will have 2x squared minus 7x plus 3. Now I hope we're good at factoring because that's what we have to do next. I know some people like the guess and check, so I'm going to show that for the 6x squared minus 7x plus 2. So how will that factor? So I need to make 6x squared. So I'm going to try 3x and 2x. This is the guessing and checking. And then I need to get a negative 7 in the center, okay? And a 2, and we have to have 2 for our C, so we could do 2 and 1. 2 times 1 is 2. They would both have to be negative, though, to get a negative 7. And I think that actually I got lucky, and on the first time it worked, because if I distribute, I get 6x squared. Don't write this because I'm going to erase it. Here I get negative 3x, here I get negative 4x, and here I get positive 2. So I'm just going to take those off. It checks. That's the guessing and checking. If you don't want to do the whole multiplying 6 times 2 and then grouping method. And I'm just doing that because We don't have a lot of space here or a lot of time, and we have to factor lots of things. So the numerator, or the denominator, I just factored out of 4. Then, this one's nice because it's in the form x and x. There's no coefficient in front of x. To get 6, I can do 6 and 1 or 2 and 3. 6 and 1 will give me, let's see. They both have to be negative because the 5 is negative. So negative 3 and 2 will give us a negative 5, but when you multiply them, you get a positive 6. Okay, and in the denominator, it's going to be a guessing and checking again. So I have to get 2x squared, and 2x times x gives us 2x squared. Then we want a positive 3 and a negative 7, so they're both going to have to be negative, because a negative times a negative will give us a positive 3. I'm going to put the 3 here so that these multiply to give us negative 6, and then I'll put the 1 here so that we get negative 1. And negative 1 and negative 6 equals 7. All right, let's see if we can cancel anything. Right now I'm only seeing this as being able to cancel. And then I'm going to rewrite it. Oh, I see one more thing that can cancel right here. 3x minus 2, x minus 3, and in the denominator we have a 4, and x. Oh, another x minus 3. I didn't see those ones, so I'm just going to erase those. And this is our final answer. And maybe put the 4 in the center. So pretty cool that it simplified that far down. I'd like you guys to try D in your groups. Rational functions. A rational function is a function of the form Rx equals P of Q over Q of X, where P of X and Q of X are polynomial functions and Q of X is not 0. So in this section, we're going to learn about domain. The domain of a rational function is all real numbers except for those values that would cause division by 0. We must eliminate any values that make Q of X 0. And to figure out the domain, we set the denominator equal to 0, then we solve the equation, and the domain is all real numbers excluding the values found in step 2. So they want us to find the domain of this. So we're going to set the denominator equal to 0. And we're going to solve the equation. So we're going to factor to be able to solve. Factoring out a GCF of 4. And then there are factors of negative 5 that add up to negative 4. That would be x minus 5 and x plus 1. The 4 we don't really need to worry about, but x minus 5 equals 0, so x equals positive 5. And x plus 1 equals 0, so x equals negative 1. So the answer is the domain is all real numbers. I'm going to show it like this special kind of R. All real numbers. I drew that horribly. It's an R like that. All real numbers. So I'm just putting that over here in my Cornell Notes column. The domain is all real numbers excluding x equals 5 and x equals -1. All right, how do we multiply and divide rational functions? So a function is written like f of x or g of x, and in this case, we're literally just going to plug this function, f of x, into this equation, f of x. And then we're going to multiply it by g of x. So what's given to us as f of x is this, and what's given to us as g of x is this. So we're just going to multiply those like we've been doing today. So I'm going to factor this to become x and x minus 1. I'm going to factor the denominator into 3, x squared plus 9x minus 10. Then I'm going to factor the numerator into x minus 10 and x plus 10 because it's a difference of squares. Whoops. And in the denominator, I'm going to factor out an x. And this is what we get. Can we cancel anything? Yay! We can cancel these. We can cancel this x. And we can factor a little further. So I'm going to rewrite what we're left with, except I'm going to factor the x squared plus 9x minus 10. So -10, factors of -10, it's in this form, x and x. What multiplies to give you -10? A positive 10 and a -1, because that'll give us a positive 9x. And then we have x plus 10. I'm just going to play a placeholder of 1. We're not going to need it later, but this x plus 10 cancels, this x plus 10 cancels, this x minus 1 and x minus 1 cancel. So now in the denominators, I just have 3 times 1, but they're in the denominator and I have nothing on the top. So I'm going to put a 1 placeholder. And that is pretty cool because it's simplified very nicely. Right, turn the page. You are going to complete this next problem in your groups.